Okay, in the previous video we have terminated 110 IDC. 110 IDC. Remember what IDC stands for? Since it stands for Insulation Displacement Connection. Now I'm going to actually show you a couple of other termination platforms. I'm going to show you BICS, IDC. Okay. There's also 66. This thing is not writing anymore. Okay. Let's go 66 IDC, Insulation Displacement Connection. There's also CRON, IDC. What else do we have? There are other specialized connectors that you're going to get. It's impossible for me to list them all. Maybe it will be possible, but I'm not going to. Okay, I'm just going to give you some couple of most common ones. Now, today we are going to terminate something that's called toolless. Toolless IDC, Toolless Insulation Displacement Connection. So most of the time you're going to see in North America, you would see 110 for data most of the time. You will see BICS for telephony most of the time. In USA, instead of BICS, although BICS is becoming more common in the States, but you're going to see a lot of US 66 type of blocks. So notice this 110, 66, CRON, these are the names. So that 110 has nothing to do with the 110 volts or whatsoever. It's just a name of the termination platform. Okay, CRON you would mostly see in Europe and UK. It's not as popular type of connection in North America. However, that thing does exist. Okay. Now, before we get to terminating the toolless IDC, I'm going to give you a little bit of a rundown on the termination types. Okay. So here's I've queued it up in my laptop, a little slideshow here. Okay, so toolless computer networks termination, or maybe I should say data networks termination types. All right, definition. Let's start with some definition. Cable termination is the connection of the wire or fiber to a device. Okay, such as an equipment, panels, or wall outlets. Okay, which allows for connecting the cable to other cables or devices. All right, the type of connection that we're dealing with is the most common one. It's called insulation displacement connection. In the past, a lot of soldered connections were used. Soldered connections are good, except they are taking too much time, or it takes longer to perform a soldered connection. Now, when it comes to installing cables and cable structure systems commercially, the speed and the efficiency actually comes to play. So the insulation displacement connection was invented. Okay. Now it looks like this. Basically, now the one thing I'm going to point out is that I got this thing from the internet here, and you're going to be able to see the link when you download this presentation here, this slideshow. I'm going to post it on our class portal. The one thing I'm going to point is that right here, somebody included a stranded wire. Okay, stranded conductor. Stranded wire in the insulation. That is not as correct. Insulation displacement is meant to work with the solid core wires, because you're just pushing that conductor, the insulated conductor, inside the terminal. That terminal basically bites into the installation and makes a connection with the wire inside, and if you have a stranded cable, it could actually cut some of the strands, so it's not as good. It's not correct to use the stranded cables or conductors while using IDC. Okay, now this is what it looks like. Installation, displacement, connection. Now when you download the presentation, you can, if you're interested, you can read a little bit of a background on that. I'm not going to go too deep into this of how it was invented and when and why. I just give it a little bit of a rundown or synopsis of that, but you can read it if you want. Now presently in 2021, the two most common punch down platforms, punch down platform, IDC punch down, basically it's the same thing, used in Canada and pretty much in US are, well, in Canada mostly, 110 and BICS, and as I mentioned, in the States 66 platform is widely used still. All right, if you end up working in telecommunications, you will also see the 66 blocks as part of the existing or old installations. The 66 system is still used widely in USA, so if you get an installation contract from a company located south of the border, you may find a 66 block, 66 termination strip or block shipped to you as part of the installation equipment. You can decide what to do with it. The most common practice in Canada, what we do, what we found when I was working for different companies, we would just recycle the 66 blocks and replace it with the BICS system. Okay. Now, there are many punch down platforms. All right. The shapes and the forms might vary, but the purpose is one, is to organize the field wiring in a permanent and systematic way. What do we mean by field wiring? Okay, so this would be a rack location where the where everything home runs into the communications room, and the field wiring comes out of this communications room or home run location. It branches out to the field, and the field is the building, the rooms, the offices, the desktop locations, and so on. So that's considered the field wiring. Okay. Now, so it can be easy to cross-connect various points of the cabling structure. Physically permanent cabling structure makes it possible for the cable runs to be tested and or certified. What do I mean by that? Well, if you are running a permanent installation, you permanently connect into a patch panel. And what is a patch panel? Well, a patch panel is, let's say, a lot of these jacks, okay, stuck together and framed into a frame, and that is called a patch panel. And if you flip the patch panel on the other side, to the rear side, you're going to see the termination strips that associate with the jacks, front of the jacks here. Okay, so that's the whole philosophy about that is associated with the patch panel idea. Okay. Now, when when you have a permanent installation, so you run a wire, okay, and it's terminated permanently in the patch panel, and it's run inside the building, which way route it takes. Excuse me. And then it's terminated permanently in the jack, in the wall jack. So that is basically that's set in stone. It's just done. All right. Once it's terminated, nobody touches that. Okay. Now, if you want to connect this equipment, you use patch cables that you connect from the patch panel into whatever the equipment is in the rack location, the equipment rack location. But you're not playing with the permanent installation. So if you have that permanent installation done, you can test, you can run the test equipment, and you can test the parameters, you can test the link to see if it fulfills the specifications that are required for that cable to carry the signal. And then you can save that, and you can actually you can certify the link, and you can save the results in a file, and you can present it to the client. Quite often that's required, actually. Okay, so so that's what we mean by physically permanent cabling structure makes it possible for the cable runs to be tested and or certified. All right. Now this way, cross-connecting changes will not affect the physical structure of permanently installed cabling. When you cross connect, which means you're connecting those links into various parts of the equipment, and if you need to make a change, you just use the patch cord. So you just unplug it here, plug it into the different port, and plug it into the different port of whatever equipment it is, but you're not touching the permanent installation that the wire runs through. Okay. All right, so let's just take a look at some punch down platforms. BIX, that's what the BIX head looks like, and I happen to have one right here. It looks like this, and I have another punch down tool that looks like this. Let me just get a little bit of a closer view here. So basically, this is what the BIX platform looks like. Okay, and that's associated. Did I get a focus here? Yeah, that's associated with the BIX punch down head. You see here it has certain shape. See, it's made by different companies. These two punch down tools are made by different companies, so the idea of making it slightly varies, but the shape of the head is basically the same. See that? And usually the punch down tool for BIX involves a moving knife. So when I punch it here, see, the knife moves. Okay. And this one also is the same. It's BIX. It's just made by different company. Yeah, let's get rid of that. It also, you can see that the knife moves, but it's just in a different way. The first one just cuts it first and then punches, and this one punches and then cuts it off. Okay, so can we just put a little wire here? Sure we can. Just random location, and let's see what this punch down tool does for us. Okay, let's get a nice focus on the camera. All right, and you can see the insulation displacement connectors, terminals right here. There is, if you look at that here, there is one right here, and then the next one is a bit lower. It goes here. There's one here, and there is one here. You can see those insulation IDC terminals. Okay, so let's just do a little punch here and see what this does here. I'm just trying to look at the camera or actually the equipment itself. All right, now I'm just going to improvise the procedure here. Usually, you really when you punch the BIX, you really have to stop that thing. Okay, as opposed to 110, which you let the spring-loaded action do the punching force. Okay, so let's. Yeah, that's not really strong enough. You see, I'm not. Okay, here. All right. It is not. It's not reaching. The knife is not reaching properly here. Okay, let me just go. Yeah, there's one, and here's two. It's not happening. Let's try the other punch down tool. All right. It's basically because I wasn't able to properly do the stabbing action here. But oh, see, this one didn't even punch properly. Okay, let's try it again. Okay, you know what? This thing is bugging me now. Here, precede that, and I'm going to use the other punch down tool. Orient the knife. You have to. The knife orientation has to be so this part is cut off, and I'm going to prop myself against desk here. There we go. All right, and now we have a proper punch here. Can we see it under a microscope? Now you can see the, where is it? There it is. You see the cables, the conductors are being inserted into the IDC terminals, and the IDC terminals bite into the insulation and they make a connection with the copper that's inside the jacketing. Okay, so that's the BICS termination. You should not exchange. If you have a BICS punch down tool, you should only use it on BICS platform because of the shape of the head. If you have 110 jacks, you should only use 110 punch down platform, punch down tool. It looks like this. See, it has a permanent knife as opposed to permanently mounted knife, like a stationary knife, as opposed to the BICS that has a moving knife. Okay, so that's the difference between these two. Yeah. Now let's keep going with this here. So that's the BICS, and it is used on the BICS terminals. Okay, now 110. That's what the head looks like for the punch down 110 punch down tool, and this is how it is done. We have just done that in the last previous video. Now another 66. That's what the head looks like. I don't even have one here, to be honest. I'm going to admit that there's so little. There's not enough installations that we do here in Canada that involve 66 blocks, and if we have to do 1 or 2 wires connect that. I shouldn't say that, but sometimes we just use needle nose pliers. Okay. All right. Now that's what the 66 block looks like, and that's how things are being punched down onto it. All right. Then there's another one that says cron. Cron is mostly used in Europe or UK. It's also punch down system, but it's shaped a little bit differently, and that's what cron termination block looks like. The one major difference between cron and everything else is that cron on BICS and 110 you can only punch one conductor per one termination. In cron you can stack them. You can have one and you can put another one on top of it. Okay, so that's basically what cron can do for you, but then again it's not so much used in the North American continent here. Okay, examples for BICS. That's what BICS termination looks like, and 110, that's what 110 termination looks like. Okay, 66, that's what 66 termination looks like. All right. Okay, so with just a little bit of a background here now. With all these punch down tools that we use, and I don't have a cron here, I left it at school. Now BICS, here's also another example of BICS. Here and then we have the 110. Also recently, I mean a few years back right now, what we have is something that's called a Toolless Jack. Okay, Toolless termination. Now let me just present to you a Toolless Jack. Let me just get one ready for you here. All right, Toolless Jack, that's what it looks like. All right, it has a protective clip that you can remove, and once you remove that clip, make sure you don't lose that. Okay, just put it somewhere that you can find, and then that as soon as you remove that protective clip, it lets you open the hinge. Okay. Now the hinge is basically working. The hinge works as a punch down tool. You see it has those ribs here. Where's my little screwdriver here so I can point things out? There are those ribs looking like the punch down pushers. All right. Now, when you put the cable, when you put the conductor inside the groove, you're going to use the hinge to push them down and push them into the IDC. Okay. Now, there is one debris here that that was left, and that's not good, because I was from previous termination. I'm not sure if you can see it. Yeah, if I put it under microscope. All right, see, there's a bit of a piece of insulation left from the other, so I'm just going to use my screwdriver to remove that. See if I can do this here. All right, it's gone. Okay, so we can see it does have insulation displacement connectors right there. That's where you put those put the wires in. Now, if you look at a little bit like that here, you can tell that some of the connectors, some of the IDC connectors, are closer to the front of this jack here. So that's the front of this jack. And some of the connectors are closer to the rear of this jack. We have to make sure, see, I'm not sure if you can see it here. Here's one that goes this far here, and there's one that only goes this far. So they are kind of interweaved, all right? You gotta make sure that you insert the wire past that. And this is how you do it, all right? Because, let's see here. Focus. All right, let me just bring the camera down a little bit here. Can we still focus that? Yes, we can. All right. So now, when we put these, put the conductor in, we have to make sure that we go past the connector. All right. So let's say, if I put one here just like that, it is going to reach the connector right here, and the punch down, the connection is going to be made once we come down with the hinge. Okay. Now, if we do this thing same with this one here, that's not going to be far enough. We have to go past that in order for the wire to be punched properly. Okay. And the way you do it, you just come here under an angle, 45-degree angle, push it in there, and then lay it down. Okay, see, just like that. Okay, so let me just do this one here. I'm looking at the camera here. Okay, here, went under a 45-degree angle, inserted that, and lay it down. And then you can close, just push it down, and you can open the hinge. The connection has been made, as you can see. Let's see under the microscope. Here you see the conductor has been pinched by the insulation displacement connector, because that hinge came down on it and just pushed it in. Okay, so that's how we do it. All right. So that's the toolless. That's the toolless connector. And someone might ask, so why don't we just make the toolless so we don't have to buy all those termination punch down tools? Well, in some cases you're going to be dealing with the toolless jacks. In some cases you're going to be dealing with connections that involve punch down tools. And my job is to show you as much as I can, as many of them as I can. All right. So now let's get to doing the lab, actually. Okay, so our lab is going to involve 2 of those jacks. Let me just here. Okay, yes, 2 of those jacks, and they're going to come with the protective clips here. All right, so that once you insert that clip, the hinge stays locked. And there's another one here. Well, actually, it's just for the purpose of the contrast. Let's just put the black one into the white one here. All right. here. So here's the protective clip. It keeps that hinge locked in position. See, this one here can open and close. Once you do the whole termination, you put that clip right in and clip it. Okay, that's how this toolless jack works. All right, so now we're just going to remove those clips and put them somewhere where we can find them, and we're going to make one straight link involving these two jacks. Okay, so here's the front of the jack, here's the rear of the jack. Now remember, we are talking about configuration T568A or T568B. You choose which one you want to do. Last time we did A to A. Let's do this time B to B. So okay, so we have option of arranging the wires. Remember, the wires, the pairs go blue, orange, green, brown. Okay, now it doesn't matter how somebody arranged, whoever designed this jack, it doesn't matter how somebody arranged this jack here, as long as the internal connections that are inside this jack are going to produce the same effect that the other equipment wants to see. So over here everything is the same, and over here different manufacturers arrange the connections in a different way. So let's analyze this jack here. As you can tell, you can see all the stripes are on the right hand side in both cases, A or B, and all the solids are on the left hand side. Now that's important to verify, because in some companies, when they make it, some manufacturers, there could be all of them could be facing one way, and there could be one that faces the other. So just always verify that. Okay, but now when you get a job that involves installing like 200 of these, if you get a different jack, after doing 3 of those, you get into the rhythm and just keep going. Okay. Now, so this is how we are going to arrange those wires, the conductors, inside these grooves. Okay, and then we're going to close the hinge, put the clip, and it's ready to be mounted onto the faceplate. Okay. All right. So let's get a piece of wire and do the connection. Okay. All right. I got about so and so length of a wire. And remember from the previous video, this is how we strip that. Now there are devices for stripping, because sometimes when you do when you arrange the wires especially in the rack location, you need to have those wires arranged in a nice and organized and neat way. So the cables, once you dress the patch panel, they're going to have different lengths. So you basically use the let's say, okay, this wire, you just run it down, and that's how it's going to end at the rack location or the patch panel, and say, okay, we need to strip it this much. So I'm just going to make a little mark here. All right. Well, let's just do a little bit so we don't waste as much wire. Okay, just going to do a little mark here. All right, just a little notch. There you go. I just put a little notch. That's how it is. And of course, it is important to have those wires labeled. So I'm just going to have maybe this thing here, data 07. Okay. And then do one more, because sometimes the wires rub off. I put this thing a little bit too close to that mark here. Okay. Now, where's my? Here it is. Okay. All right. So now, remember the way we stripped the wire was. Now you're going to have sometimes devices that you clip on. They are clip-on devices. You clip it on, and you just run around, and you can just basically go right onto the mark. But if you don't have one, this is what you can do. Arrange the wire like that, nick it, turn it. Oops. So you nick it first and turn it, and you nick it again, right? And that lets you break the insulation and remove that part of the insulation. Now remember, as we were talking about that, this part, because we nicked it with the side cutters, look at that. It's always going to be damaged. Okay, see, those wires are damaged here. All right, so don't use it as that. Okay, now we're going to use the rip cord to rip here, maybe like that. I'm going to use the rip cord to just rip it. Okay, just like that. We're going to go as far as we need to go. Let's say here we decided that this wire is going to go right onto that mark here. I just put it past a little bit. Okay. Now I'm just going to peel off the insulation and cut this off. Right? Always cut it off. Do not have any of the garbage hanging around here. Yeah. Right. There. So basically this is the way I do it. I just grab the ripcord and the peeled off insulation and see here, just like that, so I don't damage the wires. Yeah. Now when you use it in when you use the side cutters and the ripcord, it's not going to look as neat as if you were doing this stripping device, whatever it might be, the clip-on thing, but you're going to have clean wires, undamaged, okay, as opposed to the damaged wires here. Now, how long do we cut things off with this? Yeah. I noticed by the experimentation that when you put this jack and you run the wire about here, then this is as far as you want to cut these wires, just like that. If it's a couple millimeters longer, then that's fine. Okay, so I'm just going to cut them off that way. Make sure they're nice and straight. All right. So now we have the wires. Okay, we have pairs: blue, orange, green, brown. Blue, blue, orange, green, brown. Okay, it's untwisting on me, so we gotta be careful about that. As I just told you last time, we should keep the twist right to the punch as much as possible. Okay? Do not untwist the wires. If you untwist the wires, you are compromising the specifications of the cable. Now, let's grab one of the jacks here and start arranging the wires. First time I had that jack, somebody shipped it to me, I had a heck of a time connecting that, because I was trying to put all of the pairs at once and it just didn't work. So this is how it's done. Let's prearrange it. Okay, so we're using B configuration. So when you use the B configuration, we're going to arrange those wires in such way. Here's the brown pair with the solid on the left. All the solids are going to be on the left and the stripes on the right. So here's brown on this side, green, blue, and orange, because that's what the sticker tells us that is on this particular jack. If we wanted to use the A configuration, remember the difference between A and B is the oranges and the greens are switched, interchanged. If it's just for Cat5e, okay, Cat5e. All right, that's a Cat5e jack. It will not work with Cat6. With Cat6, you have to exchange oranges and greens and blues and browns. But if we go to Cat5e, you're just going to arrange oranges and greens. You see where the orange used to be is green, and when the green used to be is orange. Okay, simply because when it comes to Cat5e, only the two pairs are being used, the oranges and the greens. One is using for transmit and one is using for the receive of the signal. And which one is transmit, which one is receive, well, that depends on which way you are looking at it from. Okay, now which end of the wire. Okay, now so let's do the B, and if we want to have a straight link, we are going to also connect B configuration in the other jack. So let's just do this. I'm going to zoom out a little bit. All right, and focus, so just so you can see things comfortably. Okay, now let's prearrange those. So blue, green, brown, green, blue, and orange. So let's just prearrange them, and we're prearranging them so they don't jump over each other once we're trying to connect them. Okay, so here is the orange and here is the blue. Oh, it just tries to run away. Okay, so now in this case here, we're going to open the hinge. So first one is the brown pair with the solid on this side. It just shows that it's actually solid, but the sticker is peeling off a little bit. But you can tell that the stripe is further down the road here on this side. Right now we can't insert that in the grooves when they are twisted like that, so we have to untwist them a little bit. So I'm just going to untwist them just enough. Okay, so we can, and then I just grab them and shake them a little bit, so just to get rid of the residue of the twist. Okay. And we're just going to put them, remember, I'm putting them under the 45-degree angle, just so this here, the brown solid, can go past the connector here. So once we come down with the hinge, we're going to push it in. Okay, so now once we have this inserted, here, we just close the hinge all the way and open it, and the connection has been made. Okay, let's take a look. This brown pair is connected. See that? All right. As you can tell, the isolation displacement connector has bitten into the insulation and is making contact with the wire. So now we do the rest of them. So we do one pair by one pair. Next one is green and solid on this side and stripe on the other side. Do we have this thing untwisted enough? No. So I'm just going to give it a little bit extra twist here and untwist that way here. Okay. It's a bit of an art to do it. Okay, so we have this thing untwisted just enough, and we're going to insert that pair into this one. Remember, we have to go past both of those connectors and just precede them. Just like, oh, I'm looking at the camera. I don't have the 3D vision on the camera. Here, okay. So that is preceded, and then close and open. So that is also done. Which is next? The blue, okay, because we're doing the B configuration, right? So insert, close and open. Insert, close and open. Insert, close and open until you're done. Okay, so blue. All right. Here again, I'm just going to twist this thing a little bit that way here, and then untwist it that way. So we have the solid on this side and the stripe on the other side. Again, insert that into the grooves. All right. It's just a little bit harder to work on the camera here. All right, here then it is preceded. Then we're going to close it and open. Okay, that is done. And then the last one was the orange. Can we do it without untwisting it too much? Well, we'll try. Is that going to work for us or not? I might. See, both of those conductors are going past the connectors, and now we can just close it and open. All right, so now both of them are being pinched. Let's just examine our works under the microscope. All the connections have been made. See? All the wires are far enough inserted so the connection is made. Right. And then the last thing we're going to do is close the hinge for the last time, okay, and reinsert, reapply the clip. And I'm just going to get that clip here and put that in and push it in. Okay. Now this hinge is not going to open. So this is how you terminate the Cat5e. Notice the twist goes right to the end. Right? Oh, I can't open it. Twist goes right to as far as possible. That's where the twist goes. You always have to remember to keep the twist. Do not untwist the conductors. In the past, I could see some students would strip the wires about this long and then have those arranged in the grooves here, and some of them are untwisted all the way. Don't do that. Keep the twist right to the very end. It's very important. I can't say it enough. All right, so let's just apply the clip here and do the other end here. Okay, so I'm just going to mark my just going to do it about this far. Actually, no, let's go it further. Let's do it further. This is how much we need to strip. That's our stripping point. Okay. So again, I'm just going to nick it, turn around, nick it again. You can just break the insulation and see if I can have enough to grab of the ripcord here. Ripcord. All right. And I'm just going to pull it and peel it until I see my mark. All right. So let's just pretend that, okay, here it is. All right. I just made that right to that mark. And then I'm going to peel the cable, grab it, and cut the insulation off. Cut the fluff. Always cut the fluff. Okay. All right. And then remember the length that we used to that we established. All right. I'm just going to measure that length here. It works really good with me here. So you put that cable right up to here, and then just grab that. And this is as much as we want to cut off. Okay. So now we have this thing cut off. The length of the stripped conductors, and then verify again the colors. We're doing B configuration, so we go brown, green, blue, and orange. So let's just pre-arrange them that way. So we go brown, brown, green. All right, just make sure that they're there. Blue and orange. Is that how we did on the other side? I hope we did. Okay. This way you're going to have an easier time of inserting them as you put them into the jack. Okay, so now let's put those in. I'm just going to do it a little bit quicker this time. Now we have removed that clip. Remember, here's that clip. Okay, so we'll take the clip off, put it somewhere that we don't lose it, and open the hinge. If you get the brand new jack, this one has been done a few times, so it opens quite easy. But if you have a brand new jack from the bag, right off the bag, you're going to have a little bit of a harder time opening it. So don't worry, just open it. Okay. So here is brown, green, blue, and orange, and all the solids are on this side in this particular jack. So let's just untwist it enough, right? Yeah, that should do. Okay, and we're going to insert that right into the grooves. Okay, it's kind of going sideways on us, so let's just straighten them out a little bit, put them in the grooves, past the connector. See, if you do it this way, if you put it just from the back, you're going to push it beside the connector here, and you're not going to make a proper connection. So go past the connector and lay it down. Okay, and then once you do that, close the hinge and open it again. This one didn't work. Okay, see, it's a good thing that it happened. All right, it did not punch, so I'm just going to reapply that. I'm going to look at it this time instead of looking at the camera. Go past that and lay it down. I didn't untwist it enough. That's why it's just jumping out on me. Okay. Normally you would just cut it off. Yeah. You know what? Sometimes those don't want to cooperate. Yeah. Pass that and lay it down. All right, verify it before you punch it. Okay, now close it, open. Now we do have a connection here. Okay, next is green. This actually untwisted itself just enough for us. All right, go past that. Past that and lay it down. Okay, and now we can close it and open. Both of them are punched. Both of them make connection with the connector, with the terminal strip. Then here's the blue. I'll do just a little bit. Here, let me look at the connector instead of the camera here. Here, okay, done. Close it, open. Both of them have made a connection, and then the last one is the orange. Okay. Put them in, lay them down. They're past, both of them are past the connector, so now I can close it and open it. Okay. Now we have all the connections done. After the last connection, you just verify it, just give it a little bit of once over, just to just eyeball it, and then close the hinge for the last time and reapply the clip. All right, so now we have a straight link. You have B to B, so that means we have a straight link. Let's just do the testing here now. So I'm just going to arrange my camera. All right, zoom out a little bit here. And I'm just going to basically plug the patch cord that I have in this into the one of the jacks. Okay, yeah, so that's plugged in, and the other end of this cable that we have, the other end, we're going to plug it in to the other patch cable that is plugged in to the jig or to the remote device. Yeah. Wires. Yeah. Come on, there we go. Okay, so now we have basically connected this the tester to its remote device through this cable that we just made, and we're going to run the test. Hopefully nothing jumped on me. Now, can we do this? I'm just going to lay it down so we can see the tester. All right. Okay. So I'm going to press the test. Previous test has not been saved. You can save it or continue with the test. We're going to continue with the test. All right. So it's now performing it's testing different parameter of the cable that we just made. Okay, come on, come on, come on. And it passed. Okay, so let's check the wire map so we can view the results. Wire map. So okay, again we have 8 feet between this connector here and that connector right here. So 8 feet is well within, let's say, the length here. Enter. The length is pair 1. You see, it's kind of funny because one of the pairs seems 1 foot shorter than the other. In a short length like that, you might you might not get accurate results, but usually we test those cables. The lengths are 200 feet, 150 feet, up to 300 feet. Excuse me, 328 feet is the limit of end-to-end, but you never do 328 feet exactly, because remember, once you have end-to-end 328 feet, once you add the patch cords, then you're going to have the cable longer and the signal is going to get lost. If it's longer than 328 feet, you are going to have an unreliable connection. Okay, so 300 feet is the rule that we go by. If it's within 300 feet, yes, it's good, but the tester is going to test 328 feet, and if it's longer, it's going to fail you on the length test. Okay, you can view other specifications here, but we haven't studied them yet. This test is quite often the testers, and we're going to go over the testers. Some of the testers just test the wire map, which means the connections are connected to where they're supposed to be, and they're not going to do a length test. Some of the testers that are called a qualifier testers, so it just qualifies as Cat5e, for example, and it does kind of a lighter duty test. It's going to test for the length, and it's going to perform a little light duty frequency response test, and that's pretty much it. It's going to qualify it as Cat5e, and quite often that's just enough. In some cases, mostly when you start Cat6 and up, you're going to be asked to certify those cables, and certification is this basically you're going to get some more expensive equipment to actually certify it, because the tests that the equipment is going to perform are going to be more precise and more rigorous. Okay, so that's basically the link. Now, as far as, let me just get that wire here. Just going to undo the connections. Once you have that, remember the lab report is going to pretty much be the same. What I'm going to do is, what you're going to do is you're going to get those wires together just like that. All right, here. Oh, focus. All right. You're going to arrange them just like this here. I'm going to ask you to label the cables. All right. Again, I want to see the data labels. So the labels, because because it is the same cable. So one end is going to be somewhere in the communications room, and the other end of this cable is going to be way somewhere 5 rooms down the hallway in the jack, in the wall jack, for example. Now, it is very important to have those labels that are the same at both ends. So if you go to the wall location and you go, okay, so this is data jack D07 or D08 or D72. So then at the other end, you're going to have a bunch of cables coming out of the ceiling at the rack location, and you have to make sense out of that. So all the labels have to be kept. So I'm going to get you to practice labeling cable at both ends. Okay. So basically what you're going to do is you're going to point the cable just like that, and let's say you're going to have a label. Let's pick a number, D17 dot. Okay. And of course that is the old label here. And then, of course, I'm going to go D17 dot. Always put the dots. I'm going to mark you on putting the dots. So when you take the photo of this, I want you to take the photo just like that. Here. Stay there. All right. Both jacks, just like that, with the numbers visible. I'm going to mark you. I want to see that there's a proper twist on both, that the pairs twist is kept right to the end, and the labels are there, and these cables are no longer than this basically this length right here. Okay. If you have it too long, it's going to be marks deducted. If you have it too short, that's also not good, because if you have it too short, as you move the cable a little bit, this might actually work against you by having the possibility of some of those wires becoming disconnected. So you need a little bit of a playroom. Okay. So here's the length. You see the length of this device here, this piece, and it's just like that. Okay. So again, as far as the lab report, you're going to have 2 pages. Can we see it? Yeah, can see, yeah. Oh, the yellow stops writing. Okay. So we're going to have 2 pages. On one page there's going to be work order, and this time is going to be, the lab is going to be in person. So this time make sure the lab instructor signs your lab as the client. Without the signature, it's just if you haven't done it. Okay, it's that serious. And page 2, excuse me, you're going to have 2 tables. All right, just like that. And on the top table, you're going to take a shot of the screen, of the test screen. And again, as I say, do not take the whole picture of this whole device and everything that's around it. Just take the photo of the test screen. That's what we're going to now view the results. All right. Just take a picture of the test screen. And you're just going to label as test results. Right? And then over here, you're going to have those 2 jags with the data label here, with the labels on the cable, and everything else that I said to you. And how are we going to label those? Well, you can just say toolless. Well, I don't have much space here to write, so I'm just going to put an arrow here. Toolless IDC. You can put that. Okay, just right there. Right, 2 pages, PDF, first work order, 2 tables. Okay. All right, I was hoping this video would be shorter, and it is shorter. Okay, we're getting well, 59 minutes, so it's basically an hour, and the last video was longer because it was hour and 20 minutes. Okay, so that was the lab 3 toolless IDC, and I will see you in class. So during the one lab session, we're gonna have 2 hours to make the connection using the 110 punch down tool and test it, take the photos, and another connection doing the toolless connection, connect it, take the photos, get work orders filled out for both labs separately. We're going to do it in 2 hours under the within the one lab session. We have 2 hours to do both. That's plenty enough time, especially when you watched one video, you watch the other video, you know what you're going to do, and all the instructors are going to do is just walk around and answer questions and correct anything that if you're struggling with, and we're going to get you the kinesthetic support, which means hands-on support. All right. Okay, so that was lab 3. See you in class.